Welcome to ICS Arabia. Nice to see you again, and thank you for watching ICS Arabia. Today's part 3 with Andre Froneman. Welcome, Andre.
Dr. Suleiman, it's good to be on the call again. Thank you so much.
Yes, we've covered the pharmaceutical industry, and then we covered the automotive industry, and today we're going to cover something also new to this episode, which is the mining industry. So mining is quite fascinating topic in South Africa, despite of the operational technology and the security. So we're gonna know, why South Africa is popular, or what is the economy of minerals and mining in South Africa. Could you tell us about it? Why South Africa is very popular with, or is it rich with minerals and mining?
Absolutely, Dr. Suleiman. So look, South Africa has had a very long history of mining, right? If you look at the pre-industrialized mining world, approximately 40 or 50% of all the gold found globally on the planet came from Johannesburg. So we've been mining for a very long time, and we've got a strong competence. We've got a long history, and we're really good at exporting our mining skills globally. I think at this stage, mining contributes about 6% to the South African GDP. So it's a massive employer. So from a labor perspective, it's a really important to the South African economy. We export pretty much every single mineral you can think about, but our top exports is platinum, coal, and iron ore. And we've got about $2.5 trillion worth of reserves still in the ground, right? So even though we've mined a lot and we've taken a lot out, there's still a large chunk of that for us to get value from. We have some processing capability in South Africa, right? So we've got aluminium smelters and we've got lots of gold processing. But when it comes to green energy, rare earth minerals, we still have to develop a lot of processing capability for that, right? So I think from a platinum minerals group perspective, manganese, chromite, gold, and platinum, I think we have one of the largest reserves globally, and I think we are second for titanium minerals like zirconium and vanadium, right? So still that means we've got lots of value, and what that means is the equipment and all of the digital mechanisms that's being adopted globally can be well tested in the South African context, and that means we have to build a very strong OT security mechanism why we digitize some of these environments, right? So I think that's quite important. Also with the way that the market is moving to electric vehicles and to green energy, and also according to geopolitics, you'll see that minerals will become much more important now and going forward. The gold sales numbers for South Africa from May this year showed a 471% year-on-year growth, right? That's a massive amount of growth in one sector. But this is in regards to geopolitics, in regards to some of the issues we've been having with the dollar and so forth, right? There's many things that play into this. Now many of these mines that I've mentioned are all going on a digital journey, right? They want to be able to monitor, and they want to be able to improve efficiencies. Safety is, of course, the biggest concern. Is how do we extract more minerals for cheaper but safer? Right, and then so that modernization is causing a lot of cybersecurity threat vectors to come forward, and we've seen with Norsk Hydro with the Lokagoga virus that they had a $70 million impact in operations because of ransomware that hit them, right? So there's already disruption in the industry. We've already seen smelters being attacked. We've already seen big mines being attacked. So it's really important that we get a fundamental understanding of how ICS plays into the mining, the processing, the transport, the harbor, and then also maybe even from a surveying perspective, the stuff that happens before that mine actually gets developed. Now, this is quite important because mines are quite different, right? You get mines that are open cast, and predominantly they would have a dependency on GPS, and the vehicles, the Komatsu and the Caterpillars will be automated. So they'll have autonomous vehicles, and they'll use drones. And what that means is that the cybersecurity threat for the open cast mine looks much different to the cybersecurity threat for a mine that goes down effectively, right? Because if you're going down underground, you have to think about ventilation. You have to think about tracking people. You have to be able to look at ground movement, and all of these things are sensor based. All of it has to run over a robust industrial network, and of course, all of it needs to be secured. So for you to become an ICS specialist for mining, you really have to understand what the mining method is before you can actually come up with a plan to add value to that specific customer. In the industry, we see vendors like Caterpillar and Sandvik, Epiroc, Komatsu, a lot of Rockwell, a lot of Siemens, a lot of Yokogawa, some Schneider, a lot of Honeywell. But we see guys that have big equipment underground that are either electrifying the equipment, so turning it from diesel and petrol into electricity. And we also see them have a remote monitoring and management capability, which means you'll be operating the drill rig, or you'll be operating the truck from a control room, which is above ground in a safe environment, right? So that's becoming very important. And obviously, these are all things that we have to consider when we build cybersecurity profile, for this industrial environment.
Nice. I mean, that's quite different. I mean, and so many processes and devices that they use in the mining, like you said, the GPS and the drones and the ventilation system. Have you been inside one of these mines, or you don't have to?
No. I mean, if you really want to be able to understand how to put technology, I think networking is the greatest example, right? Because without networking, IC security means nothing. Right?
Yes,
if there's no network, nothing can be hacked, right? But if there is a network, the network needs to be robust and it needs to be reliable. So if you go underground, you can see practically why it's very difficult to build a network, right? The cars just drive over the actually, the networks are on the side of the walls, right? So you've got fiber coming down the mine shaft, and then you would get fiber to a certain point, and you would convert to Ethernet. And that also depends on the type of mine. If it's a coal mine, then the equipment needs to be spark-proof, and there's quite a complication around what wireless and what GSM, or not GSM, what wireless and what fiber and copper technology can be under the ground, right? But when you go under the ground, you can see how the machines bump off the routers, and how they hit the access points, and how they destroy the cables, and then so that gives you an idea of what redundancy you need to build in, not just security, but actual redundant infrastructure from a network perspective. So I've been underground many of times. Marikana is quite an infamous mine in South Africa. Some miners they shot at police officers and they all got killed. The police killed them. But I've been in that mine shop, that specific one, maybe 10 or 20 times. I had a good friend which normally forgot his blasting key in his pants. And he got home, and then we had to go back and just do the blasting at that time, right? So I had a good exposure about how it operates under the mine. But also I've been with some customers with Dundee Precious, specifically with Anglo. So as I said, every mine is different. So you can kind of develop a policy that you would think would work for that mine. But really your ICS cybersecurity framework for the mine needs to be a combination of something like 62443, and then all of the variables that's happening on the mine, and then you mix the two to get to a steady state, and I think that's quite important because, as I said, depending on if the mine is above ground or underground, depending if it's going to be gold, if maybe or chrome is like a byproduct, but depending if it's coal, the ore body that you're trying to extract plays a very big role in the type of technologies that you need to protect in that environment, right? So, and I think also the mining method also changes the type of equipment that you would have underground. Like you can do room and pillar mining, you can do like block caving, you can do narrow vein stoping, you can do long hole stoping. There's so many different mining methods. And what that means is there's different equipment under the ground that is semi-digitized, maybe semi-electrical. And so that also changes the way that you engage the customers, how he actually, the mining method that he uses to get to the stope, to blast and to remove ore,
I mean, to me, what I've seen, maybe I'm not updated. The mine's environment looks very harsh and very tough. Is it still the case, or now it's more modern and easy to go inside?
No. Look, I mean, it's still 100% that it's hot. It's wet. The air quality needs to be monitored 24/7. The ventilation needs to be monitored very precisely to make sure that all the toxic fumes are removed out of the mine, and then and fresh air is brought in. And that's actually a very, very weak point of the mine, is the ventilation system, right? Because the ventilation system needs to be modernized for you to be able to have the right air quality and also to save electricity. And that modernization is a building management system type of environment, which is easily exploitable, right? So ventilation, I think, is a key thing that mines will have to build a good strategy around remote monitoring and securing that piece of equipment. But no, it's still dangerous. There's still a lot of people that die underground. It's dirty. It's rough. The equipment needs to be extremely rugged. So if you want to you can't go and put an industrial PC underground as an edge device to be able to do your CyberVision scan or your Nozobi scan. It's not that easy, right? You need to find a panel, and normally in the mine these panels are pressurized, right? So that means inside the panel there's air in the panel that gets pushed in by a compressor so that the dust can't come into the panel. So it's pressurized. So it's not as easy for you that, like in the auto industry, you just open the panel with a key and then you put your industrial PC. It's a bit of a stronger process that you have to follow from a safety perspective and from a change control perspective for you to be able to access the panel, first of all. And then also that panel estate is a big problem. You can't just add another panel because of the cost of the compression, So getting your equipment like a CyberVision probe or Tenable probe or a Nozomi probe into those areas is a bit complicated. And you can't really take your laptop down there to just plug your laptop in to do the scan. You can't really do active query while people are busy, drilling and extracting, and that's going to be a bit no-go,
So, I mean, most of the equipment that you just mentioned, I mean, the assets, are they like divided? Some of them are inside, some of them are out, or how does it look?
Yeah, look, I think if we think about what's happening on the mine currently, right? So say we take a open cast mine, right, which is a big hole in the ground. If we have to think about the technology that is there, you would normally have a blasting area, so a place where you would have a drill, and these drills are becoming automated. So it scans that specific area, looks for weak spots, and the drill automatically puts the holes. Some of the machines also put the charges in, but that's very modern. That's still, some of that stuff is still handout, right? Then after the blasting happens, you would have scoops and you would have big automated haulage trucks, and these would extract all of that ore to a certain area where it gets crushed and it gets screened and it gets conveyed to a certain area where they do mineral concentration and then they do the actual processing of the ore body. So in that mining area, you've got the vehicles, you probably have drones, and the reason that they've got drones and cameras is to look at the slope of the mine. So if there's any movement in the slope of the mine, it could mean that the walls would collapse. I don't know if you've seen that horrible video of that big coal mine that collapsed in China, where there was about 50 vehicles that were driving and the whole mine just collapsed. So this is the reason that they've got CCTV cameras and they've got drones looking at the walls of the mine to make sure that there's no movement on them, right? And if there is movement, they have to check it first. Then they've got conveying systems sometimes. So, they would put a long conveyor system, and on these conveyor systems, they put thermal cameras connected to sometimes to the process network, sometimes to a normal IT network. Looking to see if there's failure. The mines are also building lots of solar and wind generation on the mine for themselves. Now, in our last talk, we spoke about some of the cybersecurity risk that comes with solar panels and solar inverters that are not built for cybersecurity, right? So they've got a similar issue. Then also on the mine, they've got a control room. And the control room has all of the screens where they actually monitor how these vehicles move and if the vehicles need to be serviced or changed or whatever, right? So those are some of the components that you would see on the open cast mine. Underground, it's a different story. Underground, you've got vehicles that are close to the stope. So the stope is just the area where the mining happens, right? So they do blasting. After they do the blasting, they extract that ore and they get it out of the mine effectively, right? And there's scoops and there's feeders and there's so many other things. Even trucks that spray water in certain areas. So there's a multitude of probably about 15 or 20 or 30 different vehicles involved getting that ore out of the mine before the blasting happens again. And as I said, all of them are trying to move to electrical vehicles, and a lot of the mines are trying to move to remotely operated vehicles, which will remove people from this dangerous environment. Like you can rightly think, like you said before, it's still quite a dangerous environment to operate in many cases.
And the previous topics that we covered in pharma and automotive, they had in both industries IoTs and robots. What about the mining? Do they use the robots and IoTs?
No. Yeah, so IoT they use a lot,
Yes.
but robots not so much.
So,
Look, if we think about safety for a second underground, right? We have to think about air quality, right? We
okay.
have to think about movement of earth, right? So the same way that we monitor the movement on the open cast, we have to be able to see if there's movement in the tunnels and if there's a problem with the structure of the ground, right? But then the air quality is the one thing, but they also measure for hazardous chemicals and hazardous air. So if there could be methane or could be something like that they need to actively monitor. These look like traditional IoT devices, right? But they've been running in the mine for 10, 20, 30, 40 years. We would classify it as IoT in the factory, but effectively they've been doing this for a very long time underground. So we don't see robots at all. I haven't seen a robot operate under, you get some, when they do the drilling to be able to do the blasting, that machine almost operates like a robot, but I won't call it a robot like we do in that sense. But IoT devices, definitely, there's so many sensing points underground that needs to be monitored, that there's a lot of sensing happening at any given time underground.
So they use the cloud then. So for
a lot of customers, a lot of my customers do use cloud. They try and put, say they've got an Azure or a AWS instance that they manage as mine ABC. What they try and do is to make sure that this telemetry is deposited into that instance, right? So they don't trust public cloud that much for the IoT that I've seen, but they do dispense that into their own private cloud, being their own Azure instance or AWS instance. Google Cloud in South Africa is not that big for some reason. Our customers are predominantly Azure and AWS. We've got, I think, AWS's development office has been in South Africa for a very long time. AWS has also a lot of industrial utilities when it comes to big data and predictive maintenance and robot monitoring and a lot of these things that we spoke about in the auto industry, as well as in pharma. AWS has a lot of that functionality built in for mining as well. A lot of customers like that,
Okay. What about in the automotive? You mentioned there are so many stakeholders for each line for the car factories. Is it the same in mining? Do you have to deal with many stakeholders, or it's just you're dealing with one company?
No, it's normally one company. Look, I think there's lots of different asset owners, maybe, right? So you'll see a crusher or feeder or maybe a conveyor system, which is monitored by a Metso or someone like that. And then the underground equipment is directly managed by Sandvik. And then the above ground stuff is managed by Komatsu. But when I say managed, that just means the monitoring of the health of the device, right? So that the predictive maintenance around tire wear and around when the machine's going to fail, that's monitored by an external OEM. But the actual truck is driven by a controller from the mine, right? So one is the maintenance being monitored. The other one is the actual operation of the device, which is by two separate legal entities, one by the mine and one by the owner or the OEM of that specific vehicle. Yeah.
Interesting. Okay, from process perspective or in the network, what could go wrong if it's been attacked or an insider made a mistake? What could happen? What are the scenarios, the threat scenarios that could happen in a month?
Yeah. Look, so I think there's so many to mention. As I said, from my personal experience doing like red teaming exercises on some of the infrastructure for the mining, the ventilation system is, to me, the weakest link, right? If you by any chance have the capability to get into the IT network and you do privilege escalation and you understand who all the engineers are and you pivot into the process network, you find you can get to the control station of that ventilation system.
Okay.
If you shut down the ventilation in the middle of a shift and you bypass the safety system, then this could kill everyone underground effectively, because of the air quality would just be destroyed completely. So ventilation, I think, is a really big thing. The second thing is from a cost perspective, right? So if you've got the capability to get into the mining systems, and you can just so the way that it works with mining is that if you want to be able to blast at a certain area, you need the right people with the right machinery, with the right permits, with the right fuel, with the right everything to be converged at that one area to do that specific job at that time, right? So so planning software, safety software plays a really big role in getting this done. So if you exploit these systems or disrupt them in any way, it means that you can create critical risk in that environment, right? Because the people that have to do the work won't have the right equipment with them, or it can just delay the process and then you don't get the same amount of ore out of that area, right? The second thing is if ransomware hits and you are in a processing environment. So say you're in a gold smelter or you're in an aluminium smelter. We've seen with that aluminium smelter that exploded because of someone that had a ransomware, right? So you can basically do the same thing on the smelting side if you get into that process network, right? It's quite difficult, right? Because what you need to do is you need to be able to navigate two different systems. You need to be able to hack into that environment. Then you need to be able to spoof the engineering or the HMI so that the operator and the control operator doesn't see the failure. Then you need to be able to change the values of the smelter or whatever you're trying to change. And you need to be able to disable the safety system sitting behind it. This is why I said in our last meeting, a lot of my colleagues, they would always go and they would protect the process network, but they will not protect the safety network. And it's very important. It's very important that both of these things get a fair amount of attention. People don't like touching the safety network because, I think they're scared of if introducing like an active query or a ICS scan into that area, you could effectively make a problem there. But the reality is that it's an area that is built once and almost never looked at again. The safety component, right? So shutting off valves and making sure that the oven doesn't go over a certain temperature. That network is built one and never touched again. And the process network has more changes attached to it. Very important to look after both of them. But I think ventilation would be the big thing. From a processing perspective, that would be a big thing. And then remember we spoke about supply chain. If the mine is creating 1,000 tons a day of a certain product, the way that the mine gets compensated is by selling that product, right? So you can get as much ore out of the ground as you want, but if the rail network is disrupted because of ICS cyber attack, right, or the port area is disrupted because of cyber attack, then you won't be able to get your ore out and sell it at a price. Because remember, the fluctuation of the price of ore is also a big factor. So they plan to mine a certain amount to get out at a certain time to be as profitable as they are. If there's a day delay or a month delay or whatever, it really affects the mine's profitability. So you can do an ICS attack on the mine, you can do it on the smelting, you can do it on the train systems, or you can do it at the harbor area. Any one of these would have a material impact on the mine's profitability.
Oh, okay. Interesting. That's the supply chain.
That's it, yeah.
You mentioned in the previous episode that you normally focus on remote access, visibility, etc. This is the common, the remote access and the visibility. Is it the same for mining? What do you focus on as a OT security professional?
So where we are for mining currently is a lot of the mines are asking us to do tabletop exercises. And what that means is they want to see if a certain network area is disrupted in the process network, if there are services that will be affected, right? So because they would think if there's a ransomware attack in a certain segment, does that affect conveying? Does that affect crushing? Does that affect the vehicles? Does it affect us? So they want us to scenario out what would happen if certain segments fail, right? And this is a really difficult thing to do, of course, because you need to build a digital twin of that process network, right? And then from there, try and see what the cause and effect of these challenges are. Now, for you to be able to build a digital twin of that network takes time, right? You can't just put a probe in there and scan the whole network because you don't know if it's the whole network. You need to visually inspect, go down the mine, see where the fibers are, what's connected. Then you also have to see if things are connected over Wi-Fi. Maybe the physical audit doesn't let you see everything, right? So that's the one thing. The second thing is then, again, remote access, right? Under the mine, it's very difficult in South Africa to get technical resources to do repairs, maintenance, and operations of some of these vehicles, right? These are very, very advanced vehicles coming from Europe, coming from America, coming from China. So if there's a breakage underground or something like that happens, we need a professional to be able to dial in from Europe or from China or from America to do first level analysis of the problem. And then the local South African team can do the repair based on the analysis. So not just from a process engineer that needs to do PLC changes, but also from an asset perspective, remote access is fundamental. But we follow the same architecture. We look at all of the remote access that's currently happening in the process area. We then look at the jump server and do an audit on the jump server. We then implement something like a SIOLO, and then we control and the behavior of everyone that gets through this environment. And we do it in a like a managed services type of process, right? We don't just put the technology down because the remote access is very ad hoc, unpredictable. It happens at different times. So you really need to be able to give someone access at any time, but it needs to be recorded and it needs to be cataloged and it needs to be put into safety files and all of this. So remote access is there. The tabletopping is first, the remote access is second. And then the third one is looking at all of this green energy that's now being deployed in the mines, right? It's making sure that that environment is safe and secure. The last thing that we do at the mining is also to look at security for waste treatment, for slurries, all of the waste byproduct that's created by the mine and the water treatment that is happening on the mine is protecting those environments. And that's normally a cyber vision scan. That's normally a physical audit of that environment, and then giving them an asset inventory and then telling them what the risks are in that specific area, and then either positioning a firewall in that specific area and then forcing them to have all of the best practices from 62443. So that's I think that's an area that's become quite important because every time there's a wall, like a waste slurry that breaks, the environmental impact of that is massive. That waste flows wherever it can, and it maybe goes to a village or something, and a lot of people die. So managing of this waste treatment areas has become really, really important from a liability perspective for the mines.
Okay. What about availability? It's important in the other industries that we discussed before. Is it important, availability in mining as well?
Absolutely. So safety is the first mantra of mining, right? So safety in South Africa is number one. Availability is directly linked to safety because if the machine doesn't work the way it should, then maybe someone will get hurt, right? I can give you a good example of some of the things I've seen underground. There's systems that they use that people would sit on it looks like a merry-go-round. You sit on and it takes you maybe 100 meters further, because lots of walking underground. One guy was working on this machine, and so there's a process that you need to follow. You need to detension it so that it doesn't have tension. Then you take the cable off. He just took the cable off, and because of the pressure that's in the cable, the tension, it just came back and cut the other guy almost in half, right? So that availability of that machine is fundamental in making sure that the safety is there, So I think safety is number one, and availability is linked to safety in the mining industry. They have to be very careful around putting machines down or doing active query, or it's like in automotive and in food and bev, maybe you can take a chance, right? You can take a small controlled segment. The customer agrees that, okay, that segment we can have maybe 1 hour, 2 hours of active query, and we can do that because we know there's a buffer 1 hour here, 1 hour here, there's restorability. If you break a PLC underground, it might take you like 2 or 3 days to be able to get to the mine to replace the PLC. No PLC backups. Then you have to get the backup of the code, or you have to write on the fly, right? So it's a really difficult thing for you to practice ICS controls in that area via active query and some of the stuff that we've become used to,
So it's in mining availability. Most of the time is linked to safety.
Yes.
Unlike other industries that sometimes availability isn't always linked to safety. So that's why
Look, absolutely. I've mentioned on the previous call, in the automotive industry, they've got dangerous machines, right? But these machines are put into such a operating environment that you really have to break a lot of rules. You have to jump over one barrier. You have to open a door where it says do not enter, do not enter. You have to break a lot of rules to get into the dangerous area. In mining, it's completely different. Anywhere underground, you can die immediately. I mean, you can be standing in a piece of rock and fall from the top and you're dead, right? So you don't have to put yourself in a dangerous situation. You're in danger all the time. Whereas with automotive and with pharma, you really have to do a lot of work to put yourself in a dangerous environment. Mining is always dangerous, and so that I think is a fundamental difference.
And are there many OT or security people work for the mining, or from what you've seen?
I'm actually quite happy about, in the last 3 years, you would see a lot of the mines are advertising for OT specialists, right? So you would see big guys like Anglo, big guys like Volterra, First Quantum Mine. They've built a very, very strong OT security team. Dundee Precious, I think they've built a quite nice OT security team. Not big, right? Maybe 1 or 2 people, but they've got their core function, core role at the mine is OT security. So I think that's one of the segments that I think have been throwing lots of investment into OT security, which I'm quite happy about.
Nice. What about yes? Yeah, please go on.
It makes it a lot easier when you speak to the customer, and the guy on the other side also understands a little bit about the issues that's faced, in this area. So it's good. I'm glad the customers are making that investment.
Nice. In the car industry, they have like a standard called TISIS, right? TISIS, was it?
In the auto industry, yes.
Yeah. What about in the mining? Do they have a similar standard just for the mining?
No. So for me, if I look at the big conglomerates, they follow a NIST 800 type of framework and an IEC 62443 type of frameworks. A lot of the compliance that we have underground is more related to product specification, right? So this piece of device needs to comply with a certain dust-proof, waterproof, vibration-proof. So there's very rigid standards around the technology that you can place underground. If it's in a coal area, then it's quite different, right? You're not allowed to put anything in there that can make a spark because it can explode, right? So the compliance that we see in the mining industry is mostly aimed at the type of equipment that you put down there. And this is very important if you talk about switching, if you talk about firewalling, if you talk around probes. If you want to be able to do OT visibility, you need a Tenable probe, or you need a Cisco probe, or you need a Xiaomi probe to be put down there. If they are not IP67, dustproof, sparkproof, all of that, then you can't do it in the mining industry. So that's quite important. From a cybersecurity perspective, I think 62443 is well adopted, but the equipment that can support you in your cybersecurity practice, that's a different story. It needs to be, and predominantly we would see Cisco as a lot of equipment that can work down there. You see Fortinet has some equipment that can work in a very rugged area. Even Checkpoint has some industrial firewalls that I've seen underground, but not many, right? There's not a lot. So you have to be able to pick from maybe 5 or 6 vendors that have security technology that you can take underground.
Okay. How does the Purdue model looks like in the mining industry? Let's make it more vivid, more. Can you make it so we can imagine how it looks like?
No, absolutely. So if you go to close to the stope or the mining area where a lot of the action happens, you would predominantly find pressure sensors. You would find Wi-Fi that connects the drill right? And that is not Wi-Fi that's on the IT network, right? That's part of the process network. So you would see level 0, level 1, level 2 technologies all the way from the bottom of the mine to the top of where the shaft is, right? And then from there, you would have some kind of signal room or some kind of data center where the level 3, level 3.5 level sits, right? This is the historian, this is the mine planning software, this is the safety software, this is all of the rest. And I guess a lot of the networking, well, pretty much all of the networking equipment, like the routers, the switches, the firewalls, all of that sits on that layer 2 level underground, you know. So I think from a process perspective, you would see a lot of sensors, level 1 sensors. So this is for air quality, this is for moisture, this is for dust, this is for pressure, this is for heat. Those are a lot of the sensors sitting on that field level. You have some PLCs that manage conveying systems. There's PLCs that manage different. I think there's some blasting equipment that I've seen that are panel based. There's also some pressure pumps when it comes to moving water underwater that's managed by PLCs. That's all sitting on layer 2. And as I said, as you go outside the mine, that's where you'll have the top layer of the network where 3.5 really starts. That's kind of, I think it's very flat when it comes to a lot of the customers, right? They've got one process network that pretty much caters for a lot of the service in one area, probably isolated by VLANs on that layer 2, but very flat, if you get what I'm saying, right? They don't have one specific network for blasting and one specific network for ventilation. It's quite flat in that instance.
Quite flat.
Yeah.
So I mean, there is of course an engineer workstation that manages those sensors and PLCs, right?
Yeah, not a lot.
Not a lot.
You do have panels underground, but a lot of the panels or a lot of the HMIs are moved to the control center. And the reason for that is really difficult to see. It's also really difficult to touch and manipulate if you've got lots of gloves on and with the dust and so forth, right? So there's practical reasons where some of these devices might have. It is better for you to have a color code, right? So you might have a green, an orange, and a red, and a big button, right, for you to be able to manipulate the process than it is to have a visual representation like we would see in automotive or pharma, right? So the panels do look a bit different, but that HMI, the nice screen of how the process moves forward and backward, that's
it's in the control center.
Yes, yeah.
But so the control room is similar to the engineer workstation that in most factories.
Yes, absolutely.
And
So
they can control they have visibility over what's going on inside, right?
Control and visibility, yes.
Yes, visibility using, for example, HMI or SCADA or maybe Nozumi, like you said, huh?
Yeah. So normally in these control rooms, they would have a SCADA system, and not a lot of of our customers have adopted something like a Nozomi or CyberVision into the control room. They normally adopt that into their security operations center. So this is something that I see maybe in the future, those two will converge, where the control room will have like a cyber panel that shows you your cyber risk live as the equipment. But that I think is a few years out, maybe 5 or 10 years out. Maybe someone will listen to this podcast and develop something like that, That would be nice.
So what you're saying that they don't have SOCs, right? SOCs yet in mining.
They do have security operations center, but what I'm saying is the control room where they look at the HMIs and operate the machines, there's no security there. The security is in the SOC. But I guess in the future, those two things will have to, they'll have to come together somehow.
Yeah, interesting. Well, it's interesting that you said if somebody hacked into the control room and then he can have full access to the level 1 and level 2, like you said, because it's flat.
Yes.
And he could access all the assets, and it's quite interesting. So they must be very careful, the control center. I mean, they have to secure it very well. I mean, what have you done to the control centers normally? what hardening did you use for the control center normally?
Look, so I think the first thing that we do when we do audit on a control center is to look at the operating system. So normally you would find a lot of the stuff running on Windows XP, a lot of stuff running on Windows 7. So making sure that at least there's a basic antivirus capability sitting on most of the machines that the control room is monitoring or managing. The second thing is making sure of all of the remote connections coming in and out of the control room. Now, this is quite important because if all of the remote connections are coming from under the ground or from the mine, it's okay. But sometimes there's remote connections coming from an OEM or from a machine operator or something like that, right? So that needs to be protected in full. And then building firewalling capability that really is deny all from the outside world, unless you follow a remote access process to get in, you're not getting in. And then also making sure that the operators have no way of just putting a hotspot on their phone and then plugging it into one of the stations, right? That's quite important because that's something that they all do, if they have to work at night. And
yeah, it's very common. Yes, I heard this many times.
So it's very important that we make sure that we don't allow these behaviors, because for them it's just boredom, but from a cybersecurity perspective, this is not good.
Yeah, and of course they do have a DMZ zone and normally. Okay.
Yeah. No, absolutely. Look, I think when it comes to the way that the mines have architected their cybersecurity on their IT networks, it's very advanced. They spend lots of money on security teams. Some of the smartest people I've met in the cybersecurity space do come from the mining sector, right? And so when they look at OT as a problem, right, they have the right background to understand that they have to do DMZ, that they have to do remote access, they have to do these things, right? The complexity for them is just to understand how it's going to affect the mining method and the process. That's the complexity, but they come with good skills. A lot of the mining guys come with decent skills. You'll see when we've got like the mining conventions, these guys talk about GPS spoofing. They talk about, RFID hacking. They talk about, hijacking UAVs and, getting into the autonomous vehicle code and changing stuff. They're very advanced in their thought process. It's just implementing the security controls that they have in mind, in not interfering with the mining process.
And what about the ventilation systems? Are they like HVAC systems or different? Or
they're very, very, very similar, right? So you would have something like a Schneider or a Honeywell control system, and the difference between the HVAC and the ventilation system in the mine is that the ventilation system in the mine actually takes telemetry in from the mine, right? So there's lots of sensors on each shaft. And so the mining, that ventilation system needs to understand what the pressure is, what the quality is in different areas. And then it changes the way that it dispenses air underground. Yeah. So where we would have an HVAC system, they've got AI and it says you keep the building cold this way, but there's no real feedback coming back from the HVAC to say that this is how you do. In the mine, it's two-way. And that makes it a little bit different,
Interesting.
Kind of works like a PLC, right? You've got inputs, and then it changes the air quality as it dynamically reads the quality of the air in the shafts.
All right. And like you said, it's very difficult to upgrade or change the equipment inside the mines because it's very difficult. So upgrading is quite challenging for the mining industry. Have you seen old PLCs and stuff like that?
Okay, so I have to. Yeah, no, absolutely. I mean, there's some areas we saw a presentation from, I think it was from Cisco. Morad is the guy's name, where one of the customers in the cement industry, they've actually cemented one of their Cisco switches closed in the ground, and it was still moving packets around, and it was still doing deep packet inspection for 4 years. It's cemented under the ground, right? So we see a lot of this. The lucky thing in mining is that equipment gets destroyed all the time, right? So there's opportunity for you to replace equipment when it gets destroyed. If I take the automotive industry as an example, they would buy Rockwell or Cisco switches. The switch will last 20 years. It doesn't break, right? But no one bumps against it. There's no truck that drives against it. It's a different environment. In mining, you could put a piece of AP now, tomorrow it's gone, right?
Oh,
And
that's
yeah,
quite.
and then yeah, because think about blasting. If you think about how to bring network connectivity close to the blasting area, right? As they blast and remove, you need to extend the network to get closer
yes,
to that area. But
yes,
it's a violent environment. Anything that you bring close to it gets destroyed when you blast. You can't take it
yes,
too close, can't take it too far because that drill bit needs connectivity. And then
yes,
so there's always equipment that gets destroyed in this process, you know. And then you have to also be smart about your process network, right? It needs to have some kind of topology where if a link breaks, it doesn't destroy the network, right? So you have to think about, is it loop, is it star, or so wow, how do you configure your OT network that it doesn't go down just if a certain segment of that line goes down, you know? So
ah,
normally it would have like a double route to it, you know. But
right.
that's why that's the reason that some of the mining equipment is more modern than other areas, is because there's lots of destruction that happens underground, you know.
Oh, so I mean that's quite interesting. Saying that the life of hardware in for OT in mining is different than other industries because they don't last like the others 20, 15 years, like you mentioned, because
Yeah, it's
they're
no chance.
easily destroyed, and because of the harsh environment and because of the upgrades. So
Yeah,
it's interesting.
yeah.
So they must be the OEM making more money in the mining because keep they always keep buying hardware.
Absolutely, my friend. Absolutely. Yeah, look,
Yes.
it's a lucrative business to be in if you're selling underground equipment for mining. That I can tell you.
Yeah. Aren't there like specifically made for mining equipment, like because of the harsh environment inside?
Yeah,
Those,
yeah. I mean, so like I said a little bit earlier, there's not a lot of OEMs that you can rely on to
mm,
have equipment underground, right? Cisco's is one of them, and I'm talking about OT security specifically, right?
all
You'd
right.
have Cisco Industrial, you would have Fortinet Industrial, you'll have Checkpoint Industrial. I think HP is coming up with some industrial stuff, but I haven't tested that out yet. So there's not a lot of OEMs that you can rely on that has industrial equipment. Rockwell has some good equipment. Actually, Rockwell is very well represented in most of my mining customers, right? They've got very good footprint. But no, you know, it's very difficult for you to get good equipment, and it's quite expensive as well.
Yeah, there must be. Because the mining, they make a lot of money. That's why maybe they can afford it.
That's true. That's true.
Yeah, especially if it's gold or, like you said, platinum. Or
Yeah,
these are very,
yeah.
very expensive. Yeah, minerals.
Yeah, look, and
Interesting.
I think as the world is going to green energy, you'll see that a lot of the minerals that need to be mined have become different in importance, right? And what I mean with that is that, say you mine gold, then normally if you mine gold, there's a platinum rift next to the gold, right? So the platinum comes out of the same mine. You're actually mining gold, but you're getting platinum as well. Now platinum is becoming more important. Now, you know,
Yes.
so a lot of the new minerals will become more important. So mining will actually become will accelerate much faster with the green revolution that's happening. But that means that there'll be more investment in OT security. There'll be more investment in OT networking. There'll be more investment in OT skills to cover that gap, you know, and I think that's quite important.
Okay. So, I mean, for an OT vendor, OT security vendor who does offer services, do they make different prices based on how difficult is the mine or what kind of minerals they produce? Do these count when it comes to billing?
No, I mean from our perspective as an integrator,
Hmm.
we have different requirements to be able to work with mines in South Africa, right? The first
Hmm.
thing is the mine has a what they call a black economic empowerment
Hmm.
component, which means your
Okay.
company
Okay.
needs to be 50% black owned, or they can't work with the mine.
Hmm.
So there's a cost involved there. The second thing is the safety files and the safety briefings and the safety gear and the safety files and the health files are all something that you have to consider. So for us, maybe the mines are also very distributed in nature, right? So you can't have an OT strategy with the mine if you haven't been to all the segments of the mine. And the one mine shaft might be here, and the other one might be 200 kilometers further. The other one might be in a different province. So travel between the mining is a cost that needs to be considered,
Yes.
right? If I go to VW, I go to one factory, right? If I go to Anglo, I have to go to many places that,
Yes.
so the cost of operating OT security is more from my perspective because there's lots of area to cover. But when it
Yes.
comes to like the Nozomis and the Clarity and the Dragos and the Force Scout, they don't differentiate between verticals. Their prices are similar,
Yeah. No, I meant the guys who offer services such as
Yes,
you.
absolutely. Yeah.
It depends
Yeah,
on
absolutely.
the.
It's a bit more expensive.
If they produce gold, you will charge them more than if they produce.
I will charge more. Yes, that's it.
Okay.
And look, and I think that's actually something important that we didn't cover. A
Hmm.
lot of these mines, if they do diamonds or if they do gold, or if they do very precious material, even X-ray machines are part of the OT network, right? So
That's right. Oh,
all of the access control, the CCTV, the X-ray machines, all of the things that prevent people from stealing the diamonds and stealing the
yeah.
gold, those are also things that are normally put onto the process network, which you won't normally find in other areas, except maybe in health. In health, hospital, you would find those things on the OT network. But yeah, that's actually funny that you mentioned that. If you work for a diamond mine, then this is very difficult. They scan you and they scan you and they scan you, and it's not
And
easy.
the diamond mine, they open more attack surfaces, like such as the X-rays and the cameras, because
Exactly. Yeah.
They are connected to the network.
Correct. Yeah, and they're connected to the process network, right?
In
And
the process.
because these devices need to archive their data, traditionally they are connected to the process network and to the IT network, right? Because all
I
of
see.
these
Wow.
scans need to be filed and they need to be
Yeah.
put into a certain area and whatever. So it's important that that data goes both ways. So there is a weak link in the process network because the data goes both ways. Sometimes they put it on the SFTP and then maybe SAP just imports from the SFTP. I've seen them do that. But the guys are lazy. They would rather just have an open link and they would copy the files over to IT platform,
Interesting.
Yeah.
And were there any cyber attacks happened on the mining from your experience? I haven't done any research on this.
Yeah, so many. I think 54% of mining and metal companies have had a significant cyber attack in the last year, right? So that's
Wow.
almost half of them. Yeah. So it's becoming and the reason that ransomware operators like the mining industry is because they are cash flush and because of
Yes.
the safety component, right? So if you get ransomware into the OT network in the mine, it's really difficult for you to be able to recover, right? Because we spoke about PLC backups. We didn't even speak about HMI backups. These things are very difficult to manage, very difficult to implement. So they know they've got the control and they know that the mining customers have a good balance sheet. So from a threat actor perspective, it's a very lucrative industry for them to be able to attack. Yeah.
And what kind of attacks happen normally, like remote access attacks or?
Yeah, so exactly that, right? So remote access attacks and phishing attacks are the most prevalent, right? The third attack is supply chain, right? So
Supply.
using a contractor like myself or getting in through an operator. And then the fourth one is cloud attacks. So getting in from
Oh,
cloud
yeah.
infrastructure into the IT network. And then the fifth one is just plain ransomware attacks, right? That's what happens after one of those 4 entry points.
I see. I mean, do they have to secure it? Is it compulsory for mining to do cybersecurity uh, hardening or such as the standard? Will they be fined by the government if they don't do it?
No, not yet. So most of the mines follow 27001 on the IT side, but we have a Critical Infrastructure Act in South Africa, but it hasn't been applied to industry yet. So the act has been written and it's been legislated, and the fines are well defined, but they haven't allocated it to mining or gas or to critical infrastructure yet. That part of the legal process hasn't happened yet. Once that happens, then there will be recourse for government to step in. But government normally does this different. So if there's a cyber attack, there's two risks for the mine. The one is the unions. So if there's no work to be done, then the unions normally have a big problem with the mine. And the second thing is your financials, right? It's like there's a very big financial impact.
Yes.
So even now there's no legislation. Those are the two drivers that would make sure that they have action in the space, you know.
Yes. So tell us now, before we wrap up, tell us about your opinion about mining. Do you find it interesting, boring, not worth it?
No, look, I love mining. Yeah, look, I mean, so from my perspective, you know, people don't understand mining, but mining is actually a very well thought of industry, right? You remove overburden, like, you know, all of the ground, and then you start mining, and then you've got rehabilitation, and then you fix this place over a certain amount of time. And it's got a very bad reputation because of some things that's happened in the past. But fundamentally, our way of living, there's no way that we can protect critical infrastructure if we can't mine to build the critical infrastructure, right? So mining is a fundamental part of civilization. There's no way out of it. You can't have cement, you can't have copper, you can't have electric vehicles. There's literally, you can't have a laptop. There's nothing that you can have on this planet except food that doesn't come from mining. So people don't understand that, right? The green people want to say no mining, no mining. I mean, they must go live in a cave, because they won't be able to live in a normal house if there's no mining, you know. So it's even though it might be a dirty business, it's something that needs to happen. We can't support civilization without it. So for me, protecting mining is good. We spoke about ESG a little bit on the other call, but using cybersecurity to get extra telemetry out of the mine to make sure that they optimize the way that they operate, for them to be able to operate greener and to be able to make more profit. I think those are very important things that from an OT perspective, it's possible for us to do. So I'm excited. I love going underground. I love a lot of the people that work in the mining industry. So I think it's a great industry to be involved in. We definitely need more skills. So we need younger people to get more involved. We need them to be exposed to the mining method. We need them to understand how critical mining is to everything, so that they can apply their knowledge and their flexible mindset to the problem of OT security and mining.
What are the challenges for, IT people or OT security people when they go to inside the mining? Do they have like psychological problems like claustrophobia? Do they get trained for the safety? How do you find it? Do you find it? Many people find it scary to go inside, or?
Yeah, that's exactly that. I mean, I'm quite excited by going underground. For me, it's an adventure. But I've had some colleagues which found it very uncomfortable. They become claustrophobic. You know, if you go very deep underground, it's extremely hot. You know, it can get the temperatures are ridiculous. Can get up to like 20, 28, 30 degrees underground. So operating in that environment is really difficult, right? The lighting is bad. It's very warm. It's wet. So it's not the perfect environment, and I guess this is why young people wouldn't like to do it, right? You have to get your nails dirty to be able to do it. Yeah, and it's also quite dangerous. I mean, you could be underground and anything could happen at any time, right? This is like going to war. Anytime, anything can happen. You never know. Doesn't matter how much safety you follow. The geology above you, there's kilometers of ground above you. Anything can happen, you know. So a lot of people, I think that makes them nervous when going into this industry. But I think there's a lot of people that are adventurous, a lot of people that would like to do it, you know. So I wish they would.
Yeah, I mean, because like you said, it's not easy. It's rough, and it's well-known industry that has a reputation that is dangerous. So people avoid dangerous places unless they are adventurous people, such as yourself.
Yeah, look, and I mean, I can absolutely. I can also say that the mines need to pay a little bit more, and they'll get more people to come fix this OT security problem for them. You know, young people, I think, will be attracted to it if it's commercially viable for them. You know, so the second thing to consider.
So you're saying people who does OT security in mining, they get paid more than other industries?
No, I'd say they have to. They have to get paid more.
Of course. I mean, you're going inside, you're risking your life. So
Absolutely. Yeah. Look, I think from an OT security perspective, the salary base that I've seen across mining, pharma, automotive is quite the same. I haven't seen salaries kind of deviate
Doesn't make
quite
sense,
a
right?
bit.
It doesn't make sense. Maybe I think.
Doesn't make sense, my friend.
Yeah, because even here in Kuwait, if you work close to the oil field, you get paid more because of the risk.
Yes.
The explosions, the gases, it's obvious. It's different than an engineer who works in an office. It's different. So why not when working with mining, which is very, very expensive, very risky,
Yeah.
and you're working under humidity and heat, and you, like you said, you don't know what's going to happen in any minute. Why you get paid same salary? Why there is no extra bonus or something just for the mining?
Yeah, this is South Africa, man. But this is why mining has been very successful for a very long time. Is because of labor. We have can't say cheap labor anymore, but that's why they make good money in South Africa.
Yeah, but labor is different than OT security. OT security is very specialized.
Yeah, no, that's true. No, you're right. It's something I'll have to speak to them about.
Yes, please tell them to watch this part at the end of the video, and let them email me if they have any concerns.
Absolutely, my friend. Absolutely.
I'll be happily urge them to support you guys, because you're doing very, very great job in securing these mines.
That sounds good, Doctor.
Yeah, sure, man. Anything you would like before we wrap up?
No, I think from my perspective, thank you for the opportunity again. Thank you for all of the great support from all of the other ICS specialists on LinkedIn and on YouTube. I think it's a great industry to be in. And I would implore young people to get involved. Start with cybersecurity, go into processing, understand the methodology of mining, understand the method of building a car, of generating energy, and get involved. We need more people to be part of this industry, and I'm just thankful to be part of the process.
Thank you, everyone, and I hope you enjoyed the mining OT industry. I hope you found it fascinating and adventurous. If you like to take an adventure and maybe go one day mining, doing OT security under the earth with Andre. And thank you, and let's see you hopefully in the future. Thank you. Bye-bye.
Thank you.